Hello guys, welcome back to our Node.js series. In our previous video, we learned about synchronous and asynchronous execution. And at the end of that video, we were left with a few important questions. If JavaScript executes our code one statement at a time, how is it able to handle asynchronous operations? How does JavaScript know what it needs to execute right now? And what happens when an asynchronous operation becomes ready? To answer that, we need to understand two very important concepts, the call stack and the event loop. Let's start with the call stack. The call stack is the mechanism JavaScript uses to keep track of the functions that are currently being executed. Whenever JavaScript starts executing a function, that function is added to the call stack, and once that function finishes execution, it is removed from the call stack. The call stack follows a simple rule called LIFO, last in, first out. Now this might sound a little technical, so let's understand it with an example. Imagine a restaurant with a chef. The chef is preparing a dish of noodles. So the main task now is to prepare the noodles. But before the chef can finish the noodles, there is another task that needs to be handled first. The water needs to be boiled. So the chef temporarily sets the noodles aside and starts boiling the water. Now boiling the water becomes the task the chef is actively working on. Once the water is boiled, the task will be completed and the chef goes back to the earlier task, preparing the noodles. This is very similar to what happens inside the call stack. When we call a function that prepares noodles and inside it we call another function to boil water, JavaScript first starts executing the noodles function, so it enters the call stack. Then since that function calls the water boiling function, that one gets placed right on top of it on the stack and becomes the current execution. JavaScript executes the boil water function first. Once it finishes, it is removed from the stack. Then JavaScript goes back to the noodles function and continues from where it left off. Finally, once that also finishes, it is removed and the call stack becomes empty. So that's the basic idea behind the call stack. When a function starts executing, it is added to the stack. When it finishes, it is removed. And when function calls another, the new one is placed right on top of the current one. That's why we call it a stack. So far we have seen how the call stack handle normal function execution. But remember, JavaScript can also perform asynchronous operations. So let's bring an asynchronous operation into the picture and see what happens. Let's take the same example we used in the previous video. When JavaScript starts executing, the first statement logging is an asynchronous operation. It enters the call stack, executes, and prints start the program, and leaves the call stack. Next, JavaScript reaches the timer operation. Now, something different happens. This is an asynchronous operation. JavaScript doesn't keep the call stack occupied for those 2 seconds. Instead, the timer is handled by the runtime. So the JavaScript moves on to logging that enters the call stack and executes and prints end of the program. At this point, the call stack becomes empty. But what happens to the asynchronous operation we were started earlier? After those 2 seconds, the timer completes and that work is now ready to be processed. But it can't simply jump into the call stack whenever it wants. Something needs to check whether the call stack is available and decide when that work can be processed. And that's exactly where the event loop comes in. Now imagine we have a restaurant manager. The manager keeps checking the chef's working area and asking, is the chef free? If the chef is busy, the manager waits. Once the chef becomes free and the earlier work is ready, the manager brings that work to the chef. This manager represents the event loop. Now let's see exactly what the event loop is doing in our JavaScript example. We already know start the program gets printed first. Then we reach the timer operation. It is handed off to the runtime. So JavaScript doesn't wait there. It continues on to log end of the program. So end of the program gets printed. At this point, the synchronous part of our code is done and the call stack becomes empty. Now, after 2 seconds, the timer finishes. That asynchronous operation is ready to be processed. But remember, the call stack is the only place where JavaScript code actually executes. So, this completed work can't just execute on its own. It has to wait until the call stack is available. And this is where the event loop continuously checks the situation. It keeps asking, is the call stack empty? If the answer is no, it waits. If the answer is yes, and there is work ready to be processed, it coordinates that work so it can enter the call stack. Only then does the associate code actually execute. Now, what if the call stack is busy? Let's consider one more situation. What if an asynchronous operation becomes ready, but the call stack is still busy? Imagine the manager. He has an order that's ready, but the chef is currently in the middle of preparing another complicated dish. Can the manager interrupt the chef and force them to immediately handle the new order? No, the chef is already busy, so the manager has to wait. The same thing happens in JavaScript. If the call stack is busy executing code, the event loop cannot interrupt that execution. The ready asynchronous work simply has to wait. Only once the call stack becomes available can that work be processed. So remember, the call stack keeps track of the functions that are currently being executed, and the event loop coordinates the flow of ready asynchronous work. This distinction is really important. So in this video, we learned about two very important concepts, the call stack and the event loop. In our next video, we'll discuss the complete Node.js architecture. Thank you for watching and see you in the next video.